Next topic is WS addressing. So these are the set of topics we are going to cover. So we are going to learn what WS addressing is and why WS addressing is needed. And we are going to see how WS addressing is actually specified in WSDL document. And then we are going to learn the concept of message information headers that are defined as part of the WS addressing specification, WS addressing annotations that you can use in Java, and the concept of stateful web services support leveraging WS addressing. So what is and why WS addressing? So the reason that we need the new specifications such as WS addressing is because the couple of reasons. First of all, SOAP does not provide a standard way to specify where a message is going, meaning the destination. It doesn't specify where to return a response, and it doesn't specify where to report an error. Okay, because of the lack of this information in the SOAP specification, in typical web services using SOAP, these details are left up to the transport layer. So meaning you are depending on the transport layer to provide this information, destination, response, and where to report an error. So when you're using typically HTTP as a transport, the URI of the HTTP request serves the message's destination. Okay, and we're going to see that example in the following slide. And the message response is packaged in the HTTP response and received by the client over the HTTP connection. So when you're using HTTP, where to return and where to report an error is basically the sender of the HTTP request message. Now, what is the problem of this? The problem of this is, when client application has to send a SOAP message over different, let's say, transports, okay, it's quite possible along the way you might actually send to a message to intermediary node using HTTP, but from intermediary node from 1 to intermediary node number 2, you might want to use JMS. And from number 2 and number 3, you might want to use SMTP. Okay, so when there are actually multiple transports are being used along the way, the transport-specific information of the transport has to be translated from HTTP to SMTP to JMS. So certainly that's a chore. So that's the reason we need a transport-neutral mechanism for specifying addressing to web services. Okay, so that's the reason why WS addressing is born. It provides transport neutral mechanisms. What it means is that the addressing information has to be part of the SOAP message structure, meaning in the SOAP headers, instead of leaving them up to the transport. Okay, so to serve that purpose, meaning to provide the transport neutral mechanisms, WS addressing defines new constructs. It actually defines these two new concepts, I would say, endpoint reference and the message information headers. Okay, so these are basically message information headers that are going to be included in the SOAP header. Okay. So it defines the standard ways to route a message over multiple transports or direct a response to a third party. So for example, client application might send a request over JMS and ask to receive the response through email or SMS. So this is another example that you might want to actually use. You might want to use HTTP to send the request, but want to receive response in SMTP. Okay, so that is not possible without the WS addressing. Okay, so WS addressing is widely supported at the moment. So it is being supported from JAX Web Services 2.1. So let's compare transport-dependent addressing versus transport-independent addressing using WS addressing. So this is an example in which WS addressing is not used. Okay, so this is what we have used so far, because we have not used WS addressing. So this is a case where we are sending SOAP message over HTTP transport. So if you see here, this is the HTTP header, this red colored represent HTTP header. So this is the post message, and this is the URL. Okay, and this is the host. And then in the body we have a SOAP message. Okay, so we have envelope, and we have a header, and we have a body. And if you need to have a message, if you need to actually have an ID, message ID, you have to actually provide application specific the messaging ID. So you can see this Wombat is your own application. It is not a standard. Okay, so this is application created messaging ID. So messaging is not provided as part of the SOAP. So if application is concerned about actually keeping track of the messaging ID, then application has to provide its own application specific messaging ID. Okay, so this is the transport dependent addressing, in which WS addressing is not used. Okay, now if you see, this is the explanation of the slide. Okay, so basically the host example.com and dispatch method post and URL to dispatch, this URL are in the HTTP transport headers. So you can see we are using HTTP headers as a way of actually figuring out where to send a SOAP message. Okay, so this is the issue that I talked about. If the message has to be sent over alternate transport, meaning SMTP or JMS, then information conveyed in HTTP transport headers need to be mapped to SMTP specific headers. So as I mentioned, in a scenario where you have to send a SOAP message over different transport between the intermediary nodes along the message path, then this transport information, the addressing information on transport level has to be translated to another transport, HTTP to SMTP to JMS and things like that. This is because there is no standard header that identifies, and also the another issue is actually what I just talked about. There is no standard. That actually specifies a messaging ID. So this is the application application level messaging ID, and it's not standardized. Okay. So if you're using WS addressing, this now provides a transport independent addressing. So we are using this HTTP just as a transport. However, the actual addressing information is going to be specified as a standard based inside the header. So you can see we have WSA prefix, and this is the WS addressing namespace. And then we can specify three things. Messaging ID, so messaging ID is now standardized. Okay, and then we have a to and action. Okay, so we want to send, so here we are actually using email address as the destination, and then we also actually specify the action. So combination of to and action will actually specify destination, and we'll talk about the difference between to and action in the following slide. Okay, so if you compare this against the transport dependent addressing in previous slide, you can see we standardize the addressing information inside the SOAP message. Okay, so this SOAP message can be transported over different transport. Okay, and they should be able to figure out what transport scheme has to be used from this information. Okay, so message information header. So one of the things that WS addressing specifies is a message information header. So we are talking about these headers. Okay. So message information headers define full set of addressing information that can be attached to a SOAP message, and most of the fields are optional. However, mandatory fields are to and action field. Okay, and each of these is going to be in the form of URI. So if you see example of this, these two are mandatory, and message ID is optional. So let's see each of these fields a bit. So these are all possible message information headers that you can have inside SOAP header as in relevance to WS addressing. So you can have a message ID header. You can have relates to the header, and to and action. These are mandatory. Okay, and then this is from, and this is reply to. This is fault to. So these are only mandatory and rest of them are optional. Okay, so let's actually take a look at each of these in a bit more detail. So to and action URI. So all these things most of these things are in the form of URI, the actual values. Yeah, this guy, this guy, this guy, this guy, they are all in the form of the URI. Okay, so let's talk about the to and action URI. Okay, to specifies a destination. So the reason WS addressing separated out this to and action is to specify a destination, but a single destination can have multiple services. So each of those services will be represented by an action. Okay? So the to and action as a combination will specifically specify the what service on a particular destination. Okay, so this is what I just talked about. The separation of to and an action allows lots of flexibility in configuring web service destination. So email address is going to be a destination that can be specified in to, might receive multiple requests, and each of those requests might be trying to access different service, right? So in that case, that different service will be specified using action URI value. So an example is like this. So message 1 has to an action, and is actually using mail to URI, is sending this destination, but at this destination there is a service, a service, and then we have another service. Okay, so action identifies particular service on a particular destination. Okay, so optional message addressing properties. So these are other the fields, the other headers. Reply to, you probably have guessed, specify where the sender is supposed to send the response to. Okay, so it could be used to route the response to different endpoint. So it doesn't have to be the sender, right? Fault to is same thing. You might want to send the fault message to a different endpoint. So you might want to have some kind of the admin web service endpoint that collects all the faults, something like that. From service consumer identifies itself to the service. If there is a need, for the service client or service consumer identify itself to a service, then it can actually have from header. So separation of endpoints. So again, this is a repeat of what I just talked about. Explicitly separating message. So the endpoint concept I just talked about in the beginning of the presentation. So endpoints, we are talking about source endpoint, reply endpoint, fault handling endpoint. So these are the types of endpoints, and we actually separate them out explicitly. So this will help WS addressing support variety of messaging models beyond the simple request and response interactions we typically associate with the web service. So without using WS addressing, the request and response pattern is dictated by HTTP request and response pattern. Because we don't have any other way of actually specifying the patterns. Now, by leveraging WS addressing, we can have in fact the multiple interaction patterns. As I said before, you might want to have the fault message to be sent to a separate admin, the endpoint, or something like that. Okay, so message ID. So WS addressing, besides handling addressing-like information, it also actually standardizes how message ID is supposed to be included. Okay, the reason WS addressing specification addresses message ID is because when reply is done, reply should have, the message ID of the request message, right? So the WS addressing, the designers thought that, so messaging ID should be included as part of the WS addressing specification. So when reply is expected, whether it is expected by the sender or third-party endpoint specified in reply to, message ID element must be present. So message ID can be used to avoid processing the message twice. So, if reply to endpoint receive the message, it wants to know whether it has received the message twice or something like that, right? So by taking a look at the message ID, he can find out. Okay. And the reason is because the double message delivery is certainly possible because we could use web services over unreliable the internet. Relates to is it provides a standard way to associate incoming replies with the corresponding request. Okay, so yeah, so this is just associate the request with the response. All right, so let me just stop right there and see if there WS addressing annotations. So JAX Web Service 2.x specification defines the annotations that you can use to support WS addressing. So let's see how that can be done. So this is the annotation, addressing. So this annotation can be used to enable addressing. So if you are if you are, for example, doing bottom-up approach, contract last approach, in which you write a Java code and you want to create a web service WSDL from it, and if you want to support WS addressing, then you're going to use this annotation. Okay. So what gets generated? I mean, this is the WSDL that gets generated if you're using this annotation. And basically you have a namespace, WS addressing namespace, and then we are just using addressing. So you can see this is a policy statement, right? So everything we are talking about. So the domains that we talked about includes security and reliable messaging, and WS addressing is another domain where this WS policy syntax is used. So here we have exactly one and we have all. So what it means is that I want use addressing. That's basically what it means. Okay, and if you take the top-down approach, meaning you have a WSDL document like this, and if you create a Java code, then it will have a Java code with this annotation as well. Okay, so that's this basically indicating you are using annotation. Now you can also specify what is called an action. This is an action. Remember action and fault action? This is basically specifying sort of the endpoint that we talked about. So these are used to specify explicit WSA action values, and they are reflected in the port type definition of generated WSDL. Without any explicit action values, default values are used per W addressing specification. So let's see examples of what I mean by this. So the default, if action is not specified, then default will be created. Okay, and so it will actually basically, so in the absence of input and output attribute of WSA action element, the pattern of the namespace and port type and input and output name will be used as a default action. Okay, so again, let's see an example. I mean, it's pretty too abstract for you guys to see what I'm talking about. Okay, so we have a couple of examples here. So this is a case that we are using default values for actions. So we specify, so we specify an action here, okay, and it doesn't specify any input and output attributes. So the generated WSDL is going to be taken, if you remember here, we are going to take a namespace and port type name and input or output name, okay. So this is the namespace. Okay, so this is a target namespace, examples.com and numbers. So this is the target namespace. Oops, sorry. Up to this point is a target namespace, and this is a port type. Okay, so the port type is right here, right? So we take a port type and then the name of the input, so parameters. So that's the way that is going to use as an action. Okay, so this is going to be used in the address, the action, the header. Okay, and this is the result, the response. So the response message will use this guy. So again, this is the namespace up to here, and then the port type here, and then the name of the output, this guy. So this field will be used as a value of action, the header block. Okay. All right. This is an example where you specify only input. So you can specify the action with the input value. In that case, action is going to be taking the value that you specify. Okay. Otherwise, in this case, output is going to take so in that case, it's going to just take the add and it will just use the response. Okay. And this is an example where you are explicitly specifying all the input and output. Okay, so these are the values that will be used in WSDL as well as in the SOAP message. Same thing for this, and this is the same thing, and this is fault action. Okay, so this is actually the most specific way of actually specifying what you want to do with WSIT addressing. So in this case, so this example 3, the WSDL document that gets created is actually using whatever that has been specified in the in input and output, and in this case fault. Okay. So in this case, this is the value, fault action. So you can see the fault action is going to be this. So when there is a fault, the message needs to be transported. This is the value that will. This is the action header block value. Okay, and so now you can see, everything has to be specified in WSDL document. Okay, and then WSDL documents are supposed to be addressed. Will be actually understood by the client, and both client and server should be able to actually have WSIT addressing headers in the exchange of messages. So this is a SOAP message. You can see now, it contains two action, reply to, and message ID headers. Okay, and so this is the action. Yeah, so if you see, this is the action. It contains http example.com input, and that's what you see right here. Okay. And this is a response message, same deal. Okay. All right, WSIT addressing a stateful web service. So I think there was a question about how to support stateful web services. In general, the state management has to be done at the application level, meaning the application has to have some kind of state information as part of their the data. Now, by using WSIT addressing, it actually gets easier because WSIT addressing also defines a standard for including service-specific attributes within an address. So, basically, these attributes could be used for specifying some state. Okay, so this could help for building stateful the web services. Okay, but you still have to actually have some kind of stateful state information as a part of the application. If the state that is defined here in WSIT addressing is not actually, those are actually more or less the kind of framework related or framework level state information. So application level state might still have to be maintained at the application level. Alright, so that is the end of the presentation. Now let's take a look at the hands-on lab of WSIT addressing. Okay. Okay, so here what we are going to do is we are going to build web services, contract last and contract first. Well, the result is going to be the same. Okay, you are going to still see WSIT addressing being included in WSDL document as well as in the SOAP message. Okay, so let's take a look at the exercise 1. So you're going to just run the NetBeans project. Okay, so just run this project, and we are going to see WSDL document is being displayed, and you can see it's using WSIT addressing here. Okay, so observe that. So that's basically, you know, the repeat of. So I just emphasize this is the WSIT addressing namespace, and this is the WSIT addressing the element inside WSDL document. Okay, and you can see it does actually specify various actions here. Okay. All right, and you can test the code. So if you can test the code, now you can see the SOAP messages that are being exchanged, right? So test the message, and you do this, okay? And you can actually see SOAP message now contains SOAP headers that contains elements that reflect WSIT addressing, and you also see message ID right here. Okay, so this is the message that you see right here. Okay, I just emphasize with the colors. Okay, so this to action and the reply to. Okay, and so yeah, so you can see, you know, the reply to contains an address, and that's the address that is actually using. This is a response message, right? Okay. And this is the WSDL. Okay, so that's something that we have seen, and yeah, so we already kind of take a look at from the picture. Okay, and so if you take a look at the code, this is a case of contract last, meaning bottom-up approach. So we are using addressing annotation, and here we specify action, input and output. And this is yeah, so this is a method. Yeah, so we have a three method in which we have specified input and output. We have a method that doesn't specify anything, and this is the case that we specify input and output and fault. Okay, so you know, whenever this method is invoked, these are going to be used as input and output and fault actions. And this is exception. All right, so that is the server-side code. Here we are going to run WS monitor enabled client code, and we are going to capture. Okay, and yeah, since we already were able to see the SOAP messages, this is probably not that much important. Okay, if you take a look at the code, yeah, so this is, yeah, this is basic client code, nothing really WS addressing specific. Okay, client code doesn't even know it's using WS addressing underneath. Okay, so client code is all basically using application level APIs. Okay, all right, so this is the study generated WSDL. Yeah, so this is something we have already seen. Okay, so that is a contract last. Now exercise 2 is contract first. Here we define WSDL document first. Okay, so again, WSDL document, yeah, so we can actually build and run, and the interaction is going to be pretty much the same. You know, we just happen to build an application from WSDL instead of Java code. Okay, so you know, basically this is the WSDL document we start with. Okay, and so as far as the WS addressing is concerned, you know, you can skip the exercise 2, okay, because it should actually work pretty much the same. So I'm going to just move ahead. Exercise 3, I won't do it. So here we're going to actually use the net services, web services support to add WS addressing. So open Hello Web Service NetBeans project. So this is the Hello Web Service project that you have created before. And or you can just open it. The samples under NetBeans is provided for you. Okay, and you know, if you deploy the application and test the application, this is exactly the same. The Hello Web Services that we dealt with. So if you take a look at WSDL document, it doesn't contain yet WS addressing. Okay, so now in order to configure Hello World WS addressing, we're going to take advantage of the NetBeans support. So right click the web service and say edit web service attribute. Only thing you have to do is just click addressing. Okay, and what it does underneath is basically changing WSDL document for you. So you can certainly manually change WSDL document yourself, okay, but just clicking this one will change WSDL document for you. That's all. So now if you see the WSDL document, you can see this is added. So you can manually add these 7 lines of code with a namespace definition, and that's pretty much all you have to do to support WS addressing. And of course, you have to actually add actions as well, right? Okay. All right. So I'm gonna give you guys about about 15 minutes to try this exercise.